Good morning, everybody. Ni hao ma. I'm going to deliver the welcome address on behalf of Dr. Mahmoud Sol, the DG of ICADA, who was unable to attend in what is a very busy schedule. The presentation is entitled "The Growing Threat of Striped Rust Worldwide." The co-authors on the presentation, Dr. Kumar Nazari, the serial rust pathology at ICADA, who is in the audience, and Dr. Tadesse, the spring-bred wheat breeder of ICADA, is also in the presence, and Colin Wellings from Australia. So if you have any questions after the presentations, the colleagues, I'm sure, will help me to address the questions. Now, if you look into the population growth and population figures on our planet, we can realize that in 1950 there were only 4 countries with more than 100 million inhabitants. In 2011, this increased to 10 countries. We project by 2050 to have 15 countries, and by 2100, this will be 23 countries with more than 100 billion people. Currently, so we have reached about 7 billion people. By 2100, we expect to have 10.1 billion people. So increasing growth of the population on this planet. Every year, there are 73 million people added to the world population, and 93% of this 73 billion are in developing countries. So there's still about 1 billion people that go hungry to bed every night, and about 800 million people with an unsecure food security. So this is what we are up to, and if you look at the development of the wheat production, so the wheat area has been quite stable over the last 50 years, though there are pretty much 217 million hectares on which wheat is grown. Yields came up from about 1 ton per hectare to now about 3 tons per hectare. In the mid-70s and 80s, we had an increase of 1.6% per year, but it has dropped to 1.1% annual increase in the last 10 years. So the increase is some people say, reaching a plateau. And now with an annual population growth of at least 1.5%, so we have really to put all efforts together to increase yield production of wheat. And it will be very difficult to keep up with the population growth. The origin of wheat is in the Fertile Crescent in this Siwana region, the Central West Asia, North Africa region, in which ICADA is operating. In that region, there are about 52 million hectares grown to wheat. This is about 42% of the wheat area in developing countries. Now, that region is characterized by almost the highest per capita wheat consumption. It's 200 kilograms capita per year. And unfortunately, it's also a high demand and largest import region for wheat. So especially countries in North Africa, in Egypt, and the Gulf have a very high demand for wheat imports. And it's also the region with recurrent occurrence of diseases due to the co-evolution of pathogen and host. Fortunately, there is a tremendous variability in both bread and durum wheat in wheat land traces in Siwana. And if that is not sufficient, there's also the wild relatives of wheat species that are still found in many countries in Near East. The main drivers for the increase of yield in the past for wheat have been improved varieties, the adoption of input-responsive and input-efficient semi-dwarf wheat varieties, plant protection and durable disease resistance, application and adoption of inputs, so fertilizer, irrigation, herbicide, and others, the International Wheat Network, especially the centers CIMMYT and ICADA. And I also like to mention here that in the new CGIAR research project on wheat that is led by CIMMYT, 10 strategic initiatives have been formulated in order to increase wheat production and to try to increase wheat production over the 1.1% currently happening. Then the increase in international prices of wheat, the favorable policy environment, and as we have seen earlier, not really due to increase in wheat area. The wheat area has been really quite stable over the years. Now, if we focus for a moment on Siwana region, this slide is already quite old, but still the information very much relevant. So if you see the grain gap in the region, you see the consumption and the production. So if we assume a production increase of somewhere between 1% and 2%, so we still have to find, that means to import 80 to 100 million tons of wheat into the region by the year 2025. So even with all the efforts and the increases, so there's still quite a gap to fill. The challenges for an increasing wheat production are the increase of drought and water shortage, and that is the water shortage is rather increasing than decreasing. The soil degradation, the reduced supply and increasing cost of fertilizers, global warming, the new pests and diseases, and the increasing demand for energy such as biofuels. Now, the major global fungal wheat diseases are listed here, and I'm not going to argue which one is the most important. So, stripe rust, leaf rust, stem rust, septoria, tan spot, and fusarium. These are serious diseases affecting the wheat plant. Now, if we focus for a moment on the stripe rust, or the yellow rust, is a very common and widespread rust disease of wheat. It causes serious economic losses. The potential affected areas are over 30 million hectares in Siwana. The yield losses can be between 10 and 80% in Siwana, and the estimated value of crop loss per year could reach $1 billion. Here, a table on the losses due to stripe rust in a number of wheat producing countries. You see here, for instance, in the US, crop losses between 2000 and 2007 of 6.5 million tons. Australia, significant losses. China, the host country here, yellow rust is still a very severe disease. Wheat producing countries like Turkey have continuously problems with yellow rust. Iran, it's a reoccurring problem. Uzbekistan, and 2010, major problems in Morocco, Syria, and Ethiopia, Kenya, and South Africa. Known to many of the wheat researchers is the distribution, the pathway of yellow rust with west-east winds. the new races are developing in the highlands of East Africa, and from there moving across the Red Sea to Yemen, and from Yemen, and as you can see in this sketch, for the movement of yellow rust in the 80s and 90s, from there to the Middle East, from Middle East to Iran, and then from there to Pakistan and India. As we have seen with the UG99, it started very similar pathways from the highlands of East Africa to Yemen, but then from Yemen directly to Iran. And there, for the moment, it has been a little bit arrested. And so that's a very similar pathway for the distribution of the rust spores. And for the epidemics in 2010, yellow rust affecting wire 27, there were very similar pathways. The reoccurrence of yellow rust in Morocco and Turkey is, as I said, is happening frequently. In 2010, there were production loss for the cultivar Achta of 100,000 tons, worth $30 million US. The yield loss in Turkey due to the variety Gerek, there were about 40% yield losses and worth about 52 million tons, 52 million US. As you can see in this slide, so important yield losses for wheat-producing country such as Iran, Turkey, and Uzbekistan, going into the $100 million due to mainly the growth of susceptible varieties. And so you can see in years 93, 2002, 2004, 2009, these are serious losses of wheat due to yellow rust. On a global scale, you can see here the countries that are most affected by yellow rust. These are the countries marked in red. So countries like Australia, China, India, East Africa, but also US, Canada, Chile, and countries of South America are the most severe affected. And then in the second group of the orange-colored countries, so there's the Middle East, Russia, and also Canada. So these are countries very much affected by repeated events of stripe rust epidemics. The epidemiological factors that have been studied are the conducive environmental conditions, especially the problems in 2010 in the Middle East were due to very mild winters. Then the genetic similarity of the mega cultivars. In the 80s and 90s, it was the varieties that carry the YR9 resistance, and in 2000, 2010, the varieties that carried YR27 resistance, and these cultivars becoming susceptible. So it was Gerek in Turkey, Sadari in Iran, and Achta in Morocco. The means of transportation factors, the overlapping continuous cropping systems, and the widespread of alternate host and wheat wild relatives. The continuous cropping system you can see here. So in the countries in the Middle East, planting time is in November, harvest time in June. But then in East Africa and in Yemen, you see also cropping system in the off seasons or in the main seasons, so that basically over the whole year we have continuous green wheat plants in the field on which yellow rust can develop and provide an inoculum for the infection of other wheat areas. The alternate host is important. It's also berberis. We know that berberis is also the alternate host for yellow rust, and it's also available in East Africa and distributed through the Middle East, and it's worldwide distributed. But the importance of berberis for the build-up of epidemics is not completely known, and there are projects that are analyzing the importance of the alternate host for the epidemics of yellow rust. ICADA, supported or in collaboration with BGRI, FAO, and CIMMYT, is distributing the wheat rust trap nurseries to 32 countries for stem rust and for yellow rust. And also in this month, despite the pictures you might see on TV, ICADA is preparing the international nurseries and distributing and will distribute international nurseries end of this month or beginning of next month. We are still having some operations in Tel Hadia, in Aleppo, Syria. Should that not be possible to distribute nurseries from there, we have alternative sites or production facilities in Turbol, in Lebanon, or in Turkey, from where we can prepare and distribute international nurseries. As I mentioned, the mega cultivars, the genetic similarity, is one of the major reasons for the outbreak of yellow rust. In the 80s and 90s, it was the susceptibility of the YR9, and the major varieties grown in Syria and Lebanon, such as Mexipac, and genetic similar with varieties grown in Ethiopia, Iran, Pakistan, and Turkey. And in 2000 and 2010, it was a susceptibility to YR27, and here were the varieties grown in Syria, Ethiopia, Iran, and Pakistan, again with genetically very, very similar. And the similarity of the varieties and the widespread planting of these varieties led to the dramatic losses. For instance, Akhtar, the major variety in Morocco, covers 75% of the wheat area. And then if a variety such as this becomes susceptible, then this is asking for trouble. Iraq, in 2010, a major variety becoming susceptible to yellow rust. Sham 8, the major variety in Syria, covering 70% of the wheat area, and Shamran in Iran, covering 25% of the wheat area in Iran. So in 2010, we have seen a very heavy yellow rust infection in West Asia and severe losses. Now, as far as the resistance breeding strategies and methods are concerned, what we do at ICADA is to identify known and diverse sources of resistance to develop resistant parents. Emphasis is here on wild relatives and also synthetics. Targeted limited back crosses are undertaken. Segregating populations are evaluated through artificial inoculations in shuttle breeding approaches. Screening of fixed germplasm in key hotspot locations. Tel Hadia is one of them. Ethiopia, Kenya, Yemen, and Turbol in Lebanon. Undertake multi-location yield trials, the utilization of double haploid and marker-assisted selection methods to shorten breeding cycles and increase breeding efficiency. Systematic and continuous development and pyramiding of major and minor resistant genes. Efforts to combine YR10 and YR15 in a given cultivar. And new approaches, such as genomic selection, will help to combine minor genes, and those efforts need to be strengthened. Here an example of using new genetic diversity for wheat stripe rust resistance and other traits through identified through wild crosses and with wild relatives. And so in donor species like Triticum bioticum, Urartu, and Dicoccoides, we find sources of yellow rust resistance. I also believe that the work with the wild relatives, we are probably not investing enough money into this one, because these are long-term efforts. Long-term efforts are needed in order to utilize this germplasm, and I think that's an area that requires more attention. There are new cultivars have been developed, such as Khoda 1, Hammam, and Barbara, which are resistant to the new virulent races of yellow rust. They are ready for multi-location testing and for fast-track seed multiplication for distribution to affected countries. And so these are varieties that are resistant to the yellow rust, that were resistant to the yellow rust epidemics in 2010 and 2011. To highlight the importance of the stripe rust, we had organized an international wheat stripe rust symposium last year in Aleppo. And this was done in collaboration with BGRI, with CIMMYT, FAO, IDRC, Arinena, and IFAD. And what we emphasized is that a coordinated pathogen monitoring and awareness needs to be done in order to address stripe rust, with activities such as race analysis, the Global Rust Reference Center, the National Rust Laboratories, trap nurseries, and the exchange of information. Then coordinated breeding for durable resistance through the international program, national programs, the utilization of genetic resources, capacity building and training, the international and national training courses, long and short-term training, graduate students, regional traveling workshops, and the development of effective seed systems through capacity development, fast-track variety release, accelerated seed multiplication, and seed delivery. A call for action was undertaken. So 6 topics to address the stripe rust. First, the long-term investment to reduce the threat of stripe rust. If we compare stripe rust to the big brother stem rust, or UG99, so we can see that in terms of a coordinated global response, that's really lacking for stripe rust. Clearly defined targets are not there. Information system and data management are available, but not global. Surveillance networks and tools are maybe available in terms of spillovers from stem rust. Prototyping capacity, the Global Reference Center is available with some limitations. And for the yellow rust, I would say we are definitely not ahead of the disease progress. For the strategies to address the wheat stripe rust disease, disease surveillance is needed and information exchange between the countries. Planning, awareness, and preparedness to rapidly deliver appropriate seeds and fungicides where they are needed to arrest and spread of wheat rust diseases. New capacity and skills in ministry, extension service, and at the farm level to develop effective strategy for managing rust diseases. To me, that's one of the key issues, because all the research that we are undertaking, if we don't have the right policymakers and the ministries, then this is all done in vain. Crop improvement research for a continued long-term effort in developing new varieties that are resistant to the emerging pathotypes of wheat rust. Number 3 is the approaching stripe rust as a social disease. Stripe rust does not respect national borders. The rusts are called social diseases. The fight against rust requires good neighbors and working together. The role of policymakers and global leadership is crucial if we are to take a significant step forward in minimizing the impact of yellow rust. and to build a cooperative attitude for information sharing, the mutual sharing of risk analysis and trust at regional and international level. Number 4, encouraging the development of national action plans. A multifaceted approach is needed by countries to combat weed rusts. Immediate action to combat new rust pathotypes is often the use of fungicides. Reducing the cropping of susceptible megacultivars across vast wheat-growing areas is perhaps the best insurance policy against widespread rust damage. Number 5 is reducing the impacts of narrow-range variety dependence, diversified cropping of wheat, durum and red wheat, use of non-race-specific durable resistant genes, maintenance breeding as a short-term strategy, better understanding of genetic basis of resistance of current cultivars and candidate advanced lines, search and utilization of new sources of resistances from land races and wild relatives. And number 6, coordinated effective seed systems, developing a clear approach to seed multiplication and farmer engagement with new, diverse varieties, strengthening NAS and capacity development, establish fast-track variety release systems, participatory demonstration and accelerated seed multiplication of newly released wheat varieties, fast replacement of existing vulnerable commercial varieties. Through the epidemics in 2010 and 11, stripe rust has been in the news quite substantially and has drawn quite some attention. In brief, to minimize the impact of stripe rust epidemics, we need a coordinated pathogen monitoring, resistant gene monitoring in commercial cultivars, effective resistance breeding, application of fungicides, and an accelerated seed delivery system. The concluding remarks adopted from the Aleppo Declaration of the Stripe Rust Symposium are to continue research on new sources of resistance and varietal development for durable stripe rust resistance. Varietal diversification is absolute necessity in major regions of wheat, including Siwana. A short-term strategy, chemical application as an important component of stripe rust control, rapid seed multiplication of newer varieties on timely basis as a replacement strategy, timely detection and identification of new races of yellow rust, the epidemic forecasting system, to put an epidemic forecasting system in place as a regional strategy to advise agricultural ministry as a need for immediate action, and to strengthen capacity building, networking, and collaboration among different stakeholders. For durable wheat stripe rust resistance needs to be developed urgently through innovative partnerships in international research and development to protect and enhance global food security. Thank you for your attention.